All right, so we're going to pick up where we left off yesterday. So we're still working on how to find the inverse of a function. And so you need to fill in those blanks on those lines there. So if the point AB lies on the graph of f, then the point BA lies on the graph of f inverse, and vice versa. So the graph of f inverse is a reflection of the graph of f in the line y equals x. So remember yesterday how when we were, let me see if I can scroll back here. When we were checking to see if, let me find the ones where we were checking. Oops, wrong way. Got these ones here, where we had to compose, nope, not that one, sorry. This one here, where we had to compose one function with the other, and we got that they had to equal x. Well, there's a reason why that has to happen. So the reason is this, because if it's the x and y switch places. So if I have this graph here, and the point out 0 up 2 is on the graph, that means on the inverse graph, I have to have the point 2, 0. I have to flip it. So it would look like this, and they would actually reflect across this line y equals x. So that's why when they're composed together that they equal x. All right, so what we're going to do is we're going to, first we're supposed to find the inverse of the function algebraically, and then we're going to use our graphing calculator to show them in the same viewing window and describe the relationship between the graphs. Let me see what I did here. Okay, so first I'm going to start just like I did yesterday. I'm going to make that y. So y, and I'm going to switch the x and the y. So x equals 3y. And to get y by itself, I would divide by 3. So x over 3 equals y. And then I would rewrite it in my function notation. So instead of y, we're going to write f inverse of x equals 1/3 x, or x over 3 is fine. This is probably better kind of for the graphing part of it. So now I'm going to go into my calculator. I'm going to graph both y equals 3x and y equals 1/3 x. So we're going to go ahead and hit your scratch pad. We're going to do y equals 3x, and hit enter. And then I'm going to hit tab, and I'm going to do y equals 1/3 x, so control divide 1, or I could do x over 3. Let's do that. Let's do x over 3. X over 3, and hit enter. And then I'm going to put in something in the third row there. I'm going to go ahead and hit tab one more time, and I'm going to put in the line x, just an x, so you can see that reflection happening. So do you see how if I folded on that black line that I would get both the blue line and the red line? So what I'm going to do is I'm going to go ahead and sketch that into my notes. And this is like my favorite thing to do because I can just copy and paste. Nope, maybe. Let's see. There it goes. So go ahead, pause the video, and go ahead and sketch that into your notes, and that's kind of your proof. We know that the relationship between these graphs is that they're a reflection. So we would say that it's a reflection in the y equals x. All right, we're going to do the same thing for example 10, so let's try that one together. So again, I'm going to start by making that y equals, and I'm going to switch my x and my y, because every time we have an inverse, we switch the x and the y. Now I'm going to get y by itself, so I'm going to go ahead and do the opposite. So I'm going to subtract 1 from both sides. So x minus 1 equals y cubed. How do we undo the cubed? That's right, we would cube root both sides. So we've got the cubed root of x minus 1 equals y. And again, if it starts in function notation, we end in function notation. So I'm going to go f inverse of x equals the cubed root of x minus 1. All right, so we're going to go ahead and get that graphed. So I'm going to go back to my calculator. And I'm going to hit a doc B, and that erases everything. And we're going to go back to our graph, and I'm going to start with, let me find my notes on what I'm doing here. Y equals x cubed, so x to the third, maybe, plus 1. Make sure you get the plus 1 part out of the exponent. Plus 1, and go ahead and hit enter. All right, and then, oops, that's not what I wanted to do. I just wanted to move this guy out of the way. All right, and then I'm going to go to, oops, not that button, tab. And we're going to put in the cubed root of x minus 1. So the cubed root is above the caret button, so control caret. And you're going to type a little 3 in there. And x minus 1. Go ahead and hit enter. And again, just so you can illustrate this better for yourself, go do a third one and just do y equals x again. And that's hopefully really obvious that if I fold it on that line, that those graphs are symmetric. So I'm going to sketch that as well. So I'd like you to go ahead and sketch that in your notes if you need to. Pause the video. All right, once you've got that sketched, we need to answer, describe the relationship between the graphs. And again, it's a reflection in or across y equals x. And remember, whatever we do on the calculator, you could do at home just on the internet on Desmos. So you can do all of this in Desmos, but it's good for you to learn the buttons on the calculator right now. Okay, let's look at the next one. So the next one says, consider the function f of x equals x squared. Complete the following table of values for f of x. So they did it for us, right? If we put -2 in, we get -2 squared is 4, -1 squared is 1, 0 squared is 0, and so on. So fill in the following table by switching the x and the y values from the previous table. Okay, so all they want us to do is switch the x and the y values in the table. I'm going to use a different color. Or not. So I'm going to put the 4 on top and the -2 on the bottom, and the 1 on top and the -1 on the bottom. And 0 and 0, 1 and 1, 4 on the top, 2 on the bottom. So notice the second table does not represent a function since its inputs have more than one output. So remember that back from first semester, and I know it's before I came back, was like the first thing we learned. That in order to be a function, each input can only have one output, and this input here, this 4, had 2 different outputs, so that makes it not a function. So the function x squared does not have an inverse that is a function. Okay. All right, let's look at example 11. Yours is going to be a little bit different looking than mine. There was probably some values in this table here. Go ahead and just scratch them all out. I noticed this is the inverse table, and then I drew another table for f of x. So go ahead and take a minute and get those tables drawn. All right, so we're going to use the graph of the function f to complete the table and sketch it for f inverse. So really all I need to do is if I find the x and y values or the coordinates for f, all I have to do is switch them to graph f inverse. So I'm going to I happen to pick some values. You don't have to pick these, but I would find some x values that are easy to find on the graph. So I'm going to start with -4, and I'm going to trace the graph until I get to until I hit that on the graph, and then I'm going to find the y value. So I'm going to go to -4 on the x. So I'm going to -4 on the x. And we're going to come over and we're going to bring that over. Sorry, it is. And I'm reading the y value, and that y value is +4. Sorry, it's clicking all over the place. And then I'm going to go to -2 on the x, and I bring that up and draw that over. and it is 2 on the y. And then we're going to go to pot. I'm sorry that it keeps flipping like that. 2. And that is, it looks like -4 to me. Let me check and see what I wrote before. -4. And actually, I think I would rather pick this 1 value here because that looks like a key point. So instead of that 3, I'm going to pick 1. And I'm going to say that it is -1. All right, so to get the, and this is ridiculous that it keeps flipping like that. Let me try moving this a little bit. Okay, so the we need to switch the x and the y values. So in order to get my inverse function, that's our rule. So we're going to have, I'm just going to flip them. 4, -4, 2, -2, -4, 2, and -1, 1. And now I'm going to just plot those points. I'm going to use a different color though to plot them. So let's use light blue. So I'm going to go out 4 and down 4. 1, 2, 3, 4. So there's my first dot. And then out 2 and down 2. And then out -4. 1, 2, 3, 4. And up 2. And out -1 and up 1. All right, hopefully I can get this drawn right. This is the one I tend to mess up on a little bit. So again, if I looked at that line y = x, if I thought about that and I folded on that, it looks like it would fold over and be symmetric about it. All right, we're going to try it again. So, okay, so I'm going to try to figure out these values again. They may or may not be good ones I just picked, so I might have to pick differently if I need to. So I'm going to go out -4, 1, 2, 3, 4, go down, and read that the y value is 1, 2, 3, 4, -4. And then I'm going to go out to -2 and go down, and it looks like that y value is also -4. I'm going to go out to 2, and I look at that y value is actually 0. Right? If I trace that back, it would be 0. And then I'm going to go out to 3. It looks like that y value is it looks like it's almost 1. The other thing I would probably do is I'd probably grab the y value at 0 here. I know it's not on my chart, but I'm going to add it in. And the y value at 0 is -2. All right, so I'm going to go ahead and flip those. And again, I don't know why it's annoying doing that. Okay, so we're going to go, I'm going to flip the -4, -4. -4, -2, 0, 2, 1, 3, and -2, 0. I'm going to grab a different color again. Let me see if I just take the keyboard off. Maybe that's my complete problem here. Let's try that. Hang on, sorry. Okay, let's see if this works better. All right, so let's see. I need to change colors. Whoops, that's not what I wanted to do. All right, so we're going to do green. So I'm going to try plotting these. So I'm out -4 and down -4. And then I am out -4 and down 2. And I am out 0 and up 2. And then I am out 1 and up 3. Then I am out -2 and up 0. So I don't know if that's going to, let's see what that does. So we're going to go here, here, and like that. So again, if I drew that kind of line in there, it looks like it does reflect across. All right, So the next one, we've got to fill in these blanks here. So a function is one-to-one if for a and b, the domain a not equal to b, a not equal to b implies that f of a is not equal to f of b. In other words, two different x's can't have the same y. So again, we talked about this one-to-one we did first semester, so that if it's one-to-one, two different x's can't have the same y. So the way that we test that is that to tell if a function is one-to-one from its graph, do the horizontal line test. If a horizontal line graph intersects a graph only at only one y value, then the function is one-to-one. If a function f has an inverse, function f inverse if and only if it is one-to-one. Okay, so what they're saying here is we could do the horizontal or the vertical line test to decide if something is a function. So that one comes out to be a function, right? But if I did on that same graph, I did the horizontal line test, I know that the inverse is not a function because it's the original here is not one-to-one because f is not 1 to 1. All right, so we're going to skip 13. Let's go to 14. So all we're going to do is determine if the graphs determine if the graph is a function. If so, determine if it is one-to-one. So first thing I'm going to look at is the vertical line test. That one's definitely passes the vertical line test, so yes, it's a function. Then I'm going to do the horizontal line test to determine if it's one-to-one. So I look at the horizontal lines, and they don't cross more than one time, so yes, it's one-to-one. All right, so now we're going to come over here to this one, and we're going to decide if it's a function. So again, I do the vertical line test to determine if it's a function, and it only crosses one time. So we're going to say, yes, it's a function. Then I'm going to do the horizontal line test. Uh-oh, the horizontal line test failed. So this one is not one-to-one. Not one-to-one. All right, so we're going to use the graphs of f and g to evaluate the function. You guys have to be able to read values off the graph. There's just no other way to do this, and you've got to be able to do this for the next level here. So that's why you'll notice these are hand-drawn graphs, and so it was really super important that we actually practice this. So when we talk about this, you got to decide what's x and what's y, okay? So if you see inverse, f inverse of something or g inverse of something, remember that's equivalent to y. So what the value is in here is y. If you just saw f of something, that's equivalent to an x value or g of something or whatever it is. So right now I have the y value. I need to get the x value. So I'm going to go to 0 on the y-axis on the f graph. So I'm going to go to 0. And I'm going to go all the way up until I hit a value. I feel like I have the wrong answer. All right, so when I hit that value, I go 1, 2. It looks like just 2 and a little bit. So I'm going to say that x value is not, I did this wrong. I'm sorry. I apologize. I didn't go to where y is 0. Y is 0 here. So I'm going to go to where y is 0. And the x value right there is 3.7-ish. It could be 3.5, could be 3.6. I really can't tell, but it looks like a little bit more than halfway, so I'm going to go 3.7. All right, so let's try that over here. So again, it says inverse, so I know inverse is the y, so I need to calculate the x. So I'm going to go where the y value is 0 again, so y value is 0 here. I'm going to estimate, I don't know, 2.5, 2.6, 2.7, somewhere in there. All right, now we're going to do function composition. Okay, so remember that I could rewrite this as f of g of 1. So I want to start by going to 1, and remember, there's no inverse, so this is the x value. And take this x value and go to the g graph to read the y value. So we did this actually the other day. So I'm going to go to the g graph. I'm going to go to where x is 1. So I'm going to come down here to where x is 1. I'm going to read the y value off, which is 2. Then, now this becomes the new x value. I'm going to go to that on the f graph, the x value of 2 on the f graph. I'm going to read the y value off, and it's 3. I'm sorry, I did a typo. I'm blowing it today. This wasn't 2, it was -2, wasn't it? So let me fix that. So this is -2, and I'm going to go to where it's, and so I'm going to go to where it's -2, and that is 1. Okay. All right, I'm going to erase what's the scribbles that are on my graph so I don't get confused with the next problem here. Okay, let's try again. So this one, again, I'm going to rewrite it as g of f of 4. So I'm going to go to where I have the x value, because it's not an inverse, it's a regular function f. I'm going to go where the x value is 4 on the f graph. So x is 4, 1, 2, 3, 4, and I'm going to find where that is on the graph. I'm going to go over and read the y value. So I've got g of -1 I'm substituting in for the y value. Then, now this is now my new x value, and I have to figure out the y value. So I'm going to go to -1 on the g. So there's -1 on the g. I'm going to read it off, and it looks like it's -1 for the y as well. All right. Let's try this one. So this is a little bit trickier, okay? So this is the x value because it doesn't have an inverse on it. So I'm going to go to where the, and I'm going to erase on my graph again. Sorry. So that way I don't get confused. All right, so I'm going to go to the g graph, and I'm going to read where x is 3. 1, 2, 3. I must have hit pointer. Come on, come back. And it's in tablet mode, so I can't get it. Come on. There we go. Go to purple. Go to back. Okay. All right, so this is the x value. So I'm going to go to where the x value is 3 on the g graph. 1, 2, 3. I'm going to go find that on the graph. I'm going to go trace that up on the graph and read off the y value, which is 1. And then now this says, since this is an inverse, I need to look for this on the y-axis. So I'm going to go where the 1 is on the y-axis. I'm going to read where that is on the x, or read the x values off there. And you'll notice that there's 2 of them this time because it can touch in both directions. So one of my answers is -2, and my other answer, I don't know, 3.6, 3.7, your choice. All right. I'm going to erase again on my graph. Okay, let's try this again. So this again, no inverse. That's an x value, maybe. I don't know how it got so big. Come back down. Sorry, I apologize. It's doing some crazy things on me here. Okay, there we're back down to the normal size. Okay, let's try this again. So this is the x value because there's no inverse. So I'm going to go to the f graph, and I'm going to read the x value of 3. I'm going to touch my graph, and I'm going to go over and read my y, which is 3. So that g inverse of 3 gets substituted in. Now, because this is an inverse, this represents a y value. So I'm going to go to 3 on the y-axis. 1, 2, 3. And I'm going to come down and read the y value. I don't know if I'm actually on a line there. Kind of don't think I am. Let's see, how close did I get? No, I could be... Maybe I'm off. Well, let me check my -3 again. Or my 3 again. Oh, I see what I did wrong. This is wrong, this is wrong. Sorry. Okay, I was supposed to go to -3, wasn't I? So I'm going to -3, and I went to +3. So 1, 2, -3. And I read that off, and that's a 4. So now I go to the y value of 4 here. 1, 2, 3, 4. Nope, that was the x value. Sorry. Let's go to the y value of 4. 1, 2, 3, 4. My x value is also 4. All right, I'm going to rewrite this one. So g of f inverse of 4. So when I have an f inverse, I know I'm reading y. I'm going to go to the y-axis. I'm going to erase what I've got on the graphs. All right, so I'm going to go to the y-axis at 4 on the f. 1, 2, 3, 4. I'm going to find where that is, maybe. There. Okay. So I'm going to go to the y-axis at 4. Sorry, the y-axis at 4. 1, 2, 3, 4. I'm going to go find where I hit the graph, and I'm going to trace it down. And it looks like that's at -3. So g of -3. And because there's no inverse, this is an x value. So I'm going to put in an x and get out a y. So I'm going to go to -3. 1, 2, 3. And it looks like about 1, 2, 3.5. So I could go get behind 3.5 on that one. All right, then this one is f of g inverse of 4. Okay, let's erase the scribbles. They just went away, didn't they? Interesting. Okay, and my pen isn't coming back. That goes f of g inverse of 4. Okay, so we're going to go to 4 again. Inverse is y on the g. So I'm going to go to 1, 2, 3, 4 on the y. I'm going to read that value off, and you've got 4 on the x, or 4 on for the f. So I'm going to go to, this is now an x value because there's no inverse. So I'm going to go 1, 2, 3, 4. I read that value off, and I get -1. All right, let's see if we can do these last 2 examples. So use the functions f of x equals 1/4 x minus 1 and g of x equals x squared to find the indicated value or function. So it wants me to find the composition of g inverse of f inverse of -2. So what I'm going to do is I'm going to first find the inverses of those functions, and then I'm going to compose using that. So again, to find the inverses, I switch x and y. I'm going to start with this one here. So I'm going to say y equals 1/4 x minus 1. I'm going to switch the x and the y. So x equals 1/4 y minus 1. I'm going to add the 1. And then we're going to multiply by 4. So 4x plus 1 equals y. And then we're going to switch it back to inverse notation. So f inverse of x equals, and I'm going to go ahead and distribute that 4x plus 4. Okay, now we're going to do the g function. I'm going to do a different color. Do the g function. I'm going to leave myself a little bit of space there. So I'm going to do, it's really y equals x squared. I'm going to switch my x and my y. I'm going to undo this by taking the square root. Really, I should probably do a plus minus on it because it's a squared, or because that's what we do with square roots. So it's plus or minus square root of x equals y. And then I'm going to put it back in function notation. It was a g function. So g inverse of x equals the square root of x. I'm going to go ahead and drop the plus minus. I think we'll probably be okay without it. But we really should, in theory, have it there. So All right, so let's see. This is saying that we're going to do G inverse of F inverse of -2. So that means I'm taking -2 and I'm plugging it into F inverse. So let's go here to F inverse. And we're going to plug in our -2. So we've got 4 times -2 plus 4. So 4 times -2 is -8, plus 4 is -4. So now I have G inverse of -4. So now I'm going to take that -4 and plug it into here. So we've got the square root of -4, which we know how to do that, but technically it's not real. So the answer on like a test might be no real solution. But here we could say that it is -2, or that it's 2i, not -2i, but 2i, if we wanted to, because we've already seen quadratics. All right, let's look at this last one here. So it's the same numbers. Let's write that inverse from before. Let's not redo our work. So F inverse of x is 4x plus 4. So we know that F inverse of x equals 4x plus 4. So I'm not going to redo work I've already done. This is saying we're going to take F inverse of 1. Okay. So this is saying I'm taking 1, plugging it into F inverse. So let's do that. -1 into F inverse. So 4 times 1 plus 4. 4 times 1 is 4. Plus 4 is 8. So we're going to take that 8 and we're going to plug it in for the first F inverse of 1. So then I now need to take 8 and plug it into F inverse. So I'm going to plug it in. I'm just going to plug it in right here. So we've got 4 times 8 plus 4. 4 times 8 is 32. Plus 4 is 36. All right, and there should be an assignment posted on PowerSchool for you.